All right, so we're going to get started here in section 6.2 using the normal distribution. Now, in the past, we've really been looking at equations algebraically and relying on them pretty much, and we're still going to use them. But now what you're going to be using is you're going to be using graphs and the areas underneath graphs. And it's going to take a little while to get used to it. And the fastest way to get used to picturing these graphs in your mind is to graph them and draw them and see them as much as possible. So in this section, we're going to be applying the normal distribution to problems, but specifically now we're going to be looking at probabilities. We're going to be looking at areas under the curve. So when it comes to distributions, or in this case, a normal distribution, there are two kinds of functions. We have one called a probability density function, or PDF for short, and we have a cumulative distribution function, or CDF for short. Now let's look first at a PDF. So what we have here on the left-hand side is a probability density function, or a PDF, of a normal distribution with a mean of 190 and a standard deviation of 10. Now, over here on the right, let me make this blue. Over here on the right, we have a cumulative distribution function, or a CDF, also with a mean of 190 and a standard deviation of 10. So, both of these distributions look identical in shape, right? Both of them have this bell-shaped symmetrical curve. Both of them appear to be centered at 190, like this. All right, so what's the difference? Well, the difference is that the probability density function is a function that when you put in a value of x, so some number on the horizontal axis, if I put in 200 even, if I put 200 in, the probability density function will end up giving me a value of y out. So every value of x that I put into it is going to give me a value of y coming out. And this creates a set of ordered pairs, or a set of points. So a PDF is a function that will give me any point on the curve that I want. I can just put in some value of x, put it into the equation, and get a value of y out of it. And this is actually quite, what you're used to. Maybe you haven't done anything like this with normal distributions, but, in algebra, you might have had a parabola to graph. And so you could put in values of x and get a value of y out of it, and that would give you this point. So you could come up with a bunch of points, and that would tell you that this is a parabola that's going through each of those points. Same thing is going on here. We're not going to be using probability density functions, or PDFs, very much, if at all. What we're going to be mainly focused with is a CDF. And I'm trying to show you the difference between the two, because your calculator is going to have both. And so you want to know which one of the two you want to be using. All right, so like I mentioned before, both the PDF and CDF, deal with normal distributions, and they both have this bell-shaped symmetrical curve. Okay, but what makes a CDF different is a CDF, instead of giving you points on the curve like a PDF does, what a CDF does is it actually calculates the area under the curve bordered by a chosen X value. So a CDF will give you an area based off of an X value that acts as a border. Now, here, we are getting the area that is to the left of this value of X. But we could have easily used a CDF function in order to get the area to the right. And let me refresh your memory. Remember that the total area under a standardized normal distribution curve equals 1.0. Okay, sorry, my finger accidentally touched the slider here. All right, so that's the difference between a PDF and a CDF. And most functions we're going to be using are going to be CDF functions. But that's so that we can put in a value of X and get out an area that's adjacent to it. This value of X serves as the borderline to the area of interest. All right, so the types of questions that a CDF can answer is, what is the probability of randomly selecting an adult male in the United States less than 200 pounds? So what we would do is we would come up to our normal distribution here, and we erase all this so it's clearer to read. All right, come up here to our normal distribution. We would find 200, and we're interested in the probability of someone weighing less than 200. So where is less than 200? Is that to the right or is that to the left? Yeah, weights less than 200 are going to be the left. So we're interested in the area towards the smaller values, to the values that are less than 200. And so the probability of that would be 0.8413 or 84.13%. That's the value I'm getting from the area. Now, another question is, what is the probability of randomly selecting an adult male in the US that's more than 200 pounds? So now instead of looking for the probability of someone that weighs less than 200, now we want greater than 200. Well, since we're dealing with percents here, we know that the total area under the curve, the total area has to be equal to 100%. So if we're interested in finding this area above 200, couldn't we take 100 and subtract 84.13 from it? Shouldn't that give us this little area here? So 100 minus 84.13 gives us 15.87%. All right, so you can see how we can really work with the area under the curve. We just know at what point we want to cut it or splice that area, okay? So Here's an important point. From now on, almost every problem will consist of calculating the area under different shaped curves. Normal distributions, student t distributions, chi-squared distributions, and f distributions. No matter what distribution, there's a common core idea that the area under the curve is equal to the probability of an event occurring. So you really want this idea to really pound home. Okay, remember that. Area under the curve equals the probability of an event occurring. So we're going to use this to determine the probability of events occurring. We're going to use it to determine if experimental results are significant or not. We're going to use it to conduct hypothesis tests of experimental data to understand the universe. And that should have been yellow. And much more. My computer's acting slow for some reason. All right. So cumulative distribution functions, or CDF functions, relate an area under the distribution curve to values of x, which is why one uses the TI-84 plus CE function called normal CDF. Normal, because we're dealing with a normal distribution, and CDF, because we're dealing with a cumulative distribution function. That's a CDF. Right, and down below, we've got three different scenarios that we could calculate the area under the curve. So we might be interested in calculating the area to the left or less than some value of this lowercase x, in which case we'll be calculating the area adjacent and to the left of that value of x. We might be interested in calculating the probability of a value greater than some value of x. So here's our some value of x, and the probability is going to be this area above it to the right this time. Or we might want to know the probability of something occurring, an event occurring, between some lower number and upper number. So you can see here we've got a lower number. Here we've got an upper number, and we're interested in the probability or the area in between those two. Okay, so we're really diving deep here into areas under the curve. All right, let me know if you have any questions.